Let's consider then other schemes that make use of the concept of the slopes of the donor cell. Again, we're going to make use of the recurrency relationship with the fluxes at the half integer points. In this scheme, the half integer flux is approximated by this expression. Now, if the velocity is positive, this simplifies into this expression. So we see here what we have. This is simply the donor cell value, rho I, with a term here that depends on the slope of the function over the cell, which is a quantity that is still to be defined. And the different schemes differ in how they define the slope delta rho I. Then at each grid cell I, one can choose between two natural slopes to use. We can find what we call the forward slope, which is the difference between the points I and I plus 1, and the backward slope, which is the difference between the point I and I minus 1. These very simple concepts have fancy names. The first one is the Lax-Wendroff scheme, which uses the forward slope. So you define the slope here by being the forward slope, rho I plus 1 minus rho I, put that into the definition of the half integer flux, and put that back in the recurrency relationship. So this leads to a recurrency relationship that depends on the central point and the point immediately upwind and downwind. So the result is smooth, but there is considerable overshoot. Yet this overshoot does not grow much in time, which is a good feature. So it may be useful when you have irregular initial conditions. The next scheme is the beam warming scheme, which uses the backward slope. So substitute the slope delta rho I by the backward slope rho I minus 1, and again put that into the expression for the half flux and into the recurrency relationship. You end up with a scheme that uses the two first upwind points. And this is the result here. As you see, it's very similar to the Lax-Wendroff, just flipped in where the overshoot is occurring. And finally, we have the Fromm scheme. The Fromm scheme is the average of the forward and backward, so the average of the Lax-Wendroff and the beam warming schemes. You end up with a scheme then that depends on the two first upwind points and the first downwind point. The result after one period is shown here. It's smooth with some amount of overshoot. The initial shapes are still recognizable here of the Gaussian, of the triangle, and of the half ellipse. And the box got a little bit of overshoot. So far, this is the best scheme if you can accept this amount of overshoot.